An ellipse is a set of points in a plane that when you take, the best way to visualize it is if you take these 2 points, these are called the foci or foci. I've heard them either way. You can use them interchangeably. And if you take, let's see, another different color, you have this piece of string. If you move this piece of string around, okay, so if this is my string right here, and I move this around with another point, I'll get an ellipse. So the sum of this distance and this distance all the way around is how I create this ellipse here. So you have the center of the ellipse, and you have the foci right here. So when you create an ellipse, you're going to have an ellipse that's either going side to side. So we call this the major axis, and we call this the minor axis. Whatever the major axis is on, these are going to be called vertices, and then these are going to be called covertices. So you have a minor axis and a major axis. Notice that the foci will be on the major axis. Okay, so same with over here. Your foci are going to be on your major axis, but your major axis is going up and down. So this is your major, and this is your minor. So we have the covertices are, in this case, on the x-axis, and the vertices are on the y-axis. So I don't get caught up with, and I don't want you to either, I don't want you to get caught up with, the A's and the B's in these equations. I just look at, if I look at the number that's in the denominator, so if it's x squared over 9 plus y squared over 16 equals 1, because this is a standard form. It's always going to be x squared over a number, or it might not be a number, it could just be 1. X squared over a number plus y squared over a number equals 1. So there's a plus sign in between. I can tell where the major axis is because it's underneath the number that's greater. So this tells me that this ellipse is going to be stretched out on the y-axis. That means that underneath this is going to give me the vertices, and these are going to give me the covertices. And to find the foci, you always take this number is already squared, but you would do 16 minus 9 and take the square root of it, and that's going to help you get the foci. So, and I'll go over these examples here. So number 1, write an equation of ellipse that has a vertex at 0, 4. So I'm going to make 0, 4. And a covertex at negative 3, 0. And it's centered about the origin. So that means that if I went 0, 4, I need to go 0, negative 4 here. So I'm going to go 0, negative 4. And then over here on the x-axis, I'm going to go 3, 0. So here's my sketch. Didn't connect that very well at all on here, but so here's what I know about my equation. I know it has to be x squared plus y squared over numbers equals 1. Now where I get those numbers is, look at your x-axis. It is going, you have went right 3. So that means that underneath here is going to be 3 squared, which is 9. And your y, you have went up 4. So underneath here is going to be 16. So this is my equation. Second one, find the foci of the ellipse with this equation and sketch the graph. So we're going to have to step it up a notch. Not only write it in standard form, but I'm going to show you how to find the foci. So what you need to do in order to write in standard form is, you can't have this 36 right here. You need to have that be 1. So I'm going to divide everything through by 36. Okay, both the left and right hand side. So what's going to happen with my x squared is 936 is going to be x squared over 4. And then y squared over 36 equals 1. So I'm going to, because it's x squared over 4, I'm going to go right 2 and left 2. And then y squared over 36 is up 6 and down 6. So my major axes is going to be on this y-axis, and my minor axis is going to be right here. So my covertices are going to be 2, 0, and negative 2, 0. My vertices are going to be 0, negative 6, and 0, 6. So I'm going to find the foci. So to find the foci, I just take the greater number, 36, it's already squared, because the formula would be c squared equals a squared minus b squared. But I don't want to get caught up in letters. So c always represents the letter with our foci. And then I want this to be positive, so I'm going to do 36 minus 4. So it's going to be, and it's already squared, because my vertices would be at 6, 0, so 6 squared is 36. So it's going to be 36 minus 4 is 32. But then I have to take the square root of it. So c equals plus or minus the square root of 32, which is 4 root 2. Now recall that your foci are going to be on the same axis as your major axes, so your foci are going to be on the y-axis. So if I write these, foci are ordered pairs, so if I write out these ordered pairs, it's going to be plus or minus, oops, I gotta erase this and put 0. So because it's on the y-axis, it's going to be 0 plus or minus 4 root 2. I wrote that weird. Plus or minus 4 root 2. So plus or minus 4 root 2 are going to be your foci. Okay, second one, write an equation of ellipse with the foci at 0 plus or minus 4. So foci I don't really put on my graph, or I don't use it to graph. I know that the co-vertices are at negative 2, positive 2. And I know if these two are the co-vertices, it means it must be going up and down. I know that I'm going to use the formula c squared equals a squared minus b squared, where a is going to represent your vertices, and then b is going to represent your co-vertices. So if c represents your foci, it's going to be 4 squared, which is 16, equals vertices minus co-vertices. So I need these vertices to graph, so I'm going to write as a squared minus b squared, which is 2 squared, which is, I'll write 2 squared. So I'm solving 16 equals a squared minus 4. So a squared equals 20. So a equals plus or minus 2 root 5. So 20, the square root of 20, or 2 root 5, is between 4 and 5. So I'm going to go between 4 and 5, make a point, and then between negative 4 and negative 5. So I needed my vertices in order to graph it. So the relationship between the vertices, the co-vertices, and the foci are foci equals vertices minus co-vertices, and each of those are squared. So number 4, write an equation for an ellipse that has a vertex at 0, 6 and a co-vertex at 3, 0. So 3, 0, negative 3, 0, 0, 6, 0, negative 6 for it to be symmetric. Center at the origin. So to write in the equation, it's going to be x squared over, 3 squared. So that's going to be 9 plus y squared over 6 squared, which is 36 equals 1. So that's my equation. Number 5, find the following from the ellipse. Well, I need to write it in standard form first, so I have to divide everything through by 16. So it's going to be x squared over 16 plus y squared over 1, so I'll just write y squared, equals 1. So my vertices are going to be on the x-axis, because the number in the denominator of x is greater than what's in the y. So my vertices are going to be on the x-axis. My vertices are going to be at plus or minus 4, 0. And my co-vertices are going to be at 0 plus or minus 1, because they're going to be on the y-axis. So remember the relationship between to find the or among the foci, covertices, and vertices are c squared equals a squared minus b squared. So it's got to be vertices minus covertices. So it's going to be c squared equals vertices, 4 squared, which is 16, minus covertices, 1 squared, which is 1. So c equals plus or minus the square root of 15. So your foci have to be on the same axes as your vertices. So your foci are going to be at plus or minus root 15, 0. Because if your vertices are on the x-axis, then your foci need to be on the x-axis. Okay, number 6. Write an equation of an ellipse with foci at 0, plus or minus negative, or plus or minus 17, root 17, and covertices at plus or minus 8, 0. So remember that we're going to have to get our covertices, or vertices. If we know the covertices are on the x-axis, that's going to be 64 underneath here. So I don't know what that y is. So remember that c squared equals a squared minus b squared. Foci squared, so root 17 squared is 17, equals vertices, which I don't know, minus covertices, which is 64. So if I add 64 to each side, I'll get 81 equals a squared. So a is equal to 9, so my vertices are going to be on the y-axis, so it's going to be 0 plus or minus 9, which makes my equation 81, because a squared is 81.